The thing that sets kinetic and potential energy apart from each other is that one is based on motion, and that's going to be kinetic, whereas the other one, potential, is stored in a system. And so we already know that there are two types of energy that we're going to talk about in this course, but there are also subtypes of these energy, and so there are different types of kinetic energy and potential energies, and we're going to go over linear kinetic energy. So that's going to be our first subtype of kinetic energy, which is written as uppercase K sub L. And linear kinetic energy is going to describe any translational motion. So if you walked in any direction, right, southeast, south, left, north, whatever, then all of that would be considered linear motion. But if you rotated yourself, such as doing a cartwheel, so this is you in your upright position, and this is you upside down, then you're going to rotate and have rotational kinetic energy. And that's going to be written as K sub ROT. Now for potential energy, we don't have linear and rotational. We are going to have 4 different types, and they're all going to describe potential energy in different forms. So the first one is going to be gravitational potential energy, and that's written as capital U sub G. We say that an object has gravitational potential energy when it's being held up away from the Earth by some distance. For example, if you were holding a book up in the air above the ground, then it would have the potential to fall down. In fact, that's what it would do if you weren't holding it up in the air and keeping it from falling down. So the greater the distance is between the book and the Earth, the more gravitational potential energy it would have. The next type of potential energy we'll talk about is electric potential energy. And that is going to be U sub E. And electric potential energy is based off of the charge and the distance between two electrically charged objects. Like charges repel, so 2 protons next to each other would have a lot of potential energy because they would naturally go off in opposite directions. Meanwhile, a proton and an electron, since they have 2 opposite charges, they would want to become close to each other, so they don't have as much potential energy because they're already in their lowest state of stress. Then we have elastic potential energy, and that is written as U sub S because we already used up the E for electric. And elastic potential energy is affected by the internal restoring force inside an elastic material. The most common example would probably be a spring. When you have a spring and you stretch it out, then it's going to have an internal restoring force that's going to want to compress it back to its original length. And so when you stretch a spring out, it gains elastic potential energy. Finally, we have internal potential energy, which is based off of the internal frictional forces inside a system. And so the most important thing to note from today is that this is what really sets kinetic and potential energy apart, and everything below this line is the types of kinetic and potential energies that you'll need to know for now.